Hi everyone. We're going to actually be working on a 2014 AP Calculus AB free response question number 1. This question requires a graphing calculator, so if you happen to have one, take one now since we'll be using this to calculate values. So we're going to go ahead and get started. It says, grass clippings are placed in a bin where they decompose for time between 0 to 30. The amount of grass clippings remaining in the bin is modeled by A of t equals that equation, where A of t is measured in pounds and t is measured in days. So the first thing I always like to do, I just like to look at the question and understand what I'm working with. Well, they tell me that it's the amount of grass clippings remaining in a bin, and then A of t is measured in pounds and t is measured in days. Sounds simple, but you never know, because one of these questions you're always going to have to explain the meaning of what you're finding. So let's go ahead and start the question. Part A says, find the average rate of change of A of t over the interval between 0 to 30, indicate units of measure. So it's all about keywords. The keyword was average rate of change. So because we're dealing with average rate of change, we have to know what that means. Average rate of change is the same exact thing as your slope formula, y2 minus y1 all over x2 minus x1. Well, when you have that, we have x2 and x1 because that's 0 to 30, but we're missing y2, y1. That's why we have to plug in 30 and then plug in a of 0 and put it all over 30 minus 0 and then calculate our answer. So what you're going to do is just going to go on your graphing calculator, you're going to plug in 30 into this t and then 0 into this t and get your answers. And the answers you should be getting are 0.78297 minus 6.687 all over 30. Then you're going to divide that and you're going to get negative 0.1968, and that's your answer, and you're going to receive points for that. But the problem is you have to make sure you put the units, indicate units of measure. What are we dealing with? We're dealing with pounds per day. Pounds per day. And that's part A. So anytime you hear or read the word average rate of change, it means slope formula. So now working with part B. Well, part B says, find the value of A prime of 15. Use correct units, interpret the meaning of the value in context of the problem. So you have to look at it and go, okay, what's A prime? They want us to find our derivative. So we're going to find a derivative of that, but we have our graphing calculator, so there's no reason to actually find that derivative. We're just going to go to math, scroll all the way down, and you see where it says derive, type in 8 or press that button, dx, and you're going to type in the equation 6.687 parentheses 0.931 raised to the x. I'm going to use x, not t, because this function, you could use xt, doesn't really matter. Close the parentheses. And then x equals to, what are we trying to find? We're trying to find the value at 15. So I'm going to put 15, press enter, and that gives me that value. Now, when it comes to decimals, I usually round to the nearest 4 decimal places. So A prime of 15 is equal to negative 0.1636. That's your derivative at 15. But the problem is you can't just leave it like that. You have to interpret the meaning of it. Well, the meaning is, well, since this is derivative is slope, which means if it's negative, it's decreasing. So the amount of grass clippings in the bin is actually decreasing at a rate of 0.1636 for 15 days. And that's what you would put right there. Okay? You would put the amount of grass clippings in the bin is decreasing because it's negative at a rate of 0.1636 at 15 days. The rate at 15 days is negative, meaning it's decreasing. So now it's going to lead us to part C. Now, part C says, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval from 0 to 30. Okay, so when you read that, sometimes you're confused and you just want to sit there and just think about it. Find the time for which the amount of grass clippings, which is this equation because this tells us the amount of grass clippings, is equal to the average amount of grass clippings in the bin. Well, the big context clue here is average. How do we find average when it comes to calculus? hopefully we said, well, averages 1 over b minus a from 0 to 30 of your equation, respect to dt. That's how you find the average. So because of that, we have to find the average amount. And that's what we're going to do here. So finding the average amount, you're just going to type in 1 over 30 from a to b of a of t. So when we type that in, it's going to be 1 over 30 minus 0 from 0 to 30 of 6.687 parentheses 0.931 raised to t dt. And you're just going to go into your calculator. So then you're going to go to your math button because that tells you everything. You're going to scroll down to number 9 where it says integral. Press number 9 and then put 0 to 30. Problem is we never put 1 over 30 in the front. So then we're going to clear it all out. Type in 1 divided by 30. Math, number 9, 0 to 30. And then type in the equation that you already have. 6.687 parentheses 0.931 raised to the x respect to x, and you're going to get a value of 2.7526. Remember, round to 4 decimal places. So that's the average amount of grass clippings. But the problem is they were asking us at what time, going back to the question, at what time is this equal to the average? So then we're going to go, okay, well, at what time? So then that means that that original equation, 6.687, 0.931 t equals to 2.7536. Because it wants to know when this time, at what time of the original equation is equal to the average amount. So this becomes a problem where it's just algebra. How do we solve for this? Because t is in the exponent, it probably means we're going to be using ln. So I'm going to divide by 6.687. That's going to give us 0.931. T equals to 0.41164. Then I'm going to apply ln to both sides. Bring the exponent to the front by the power rule. So then t is equal to ln 0.41164 all over ln 0.931. And you're going to type that into your calculator and you're going to get a value of t equals to 12.4148. And that is the time for when it's equal to the average amount of grass clippings. Okay, so sometimes you just have to sit there and interpret the question and break it up into pieces. So that's going to lead us to part D. So in part D, it says, for time greater than 30, LT is the linear approximation to A at t equals 30. Is a better model for the amount of grass clippings in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. So we have to kind of understand this question. This is a two-part question. It wants us to find a linear approximation, and then we have to sit there and go, well, what is linear approximation? How do we even find that? Linear approximation is the same exact thing as a tangent line. So then what I'm going to do is I'm going to set this equation up as if I were solving just for the tangent line at time t equals 30. Well, we know tangent line problem is y minus y1 equals to m parentheses x minus x1. Where m is your slope, x1 is a value that we're looking for, which is at 30, and we're missing y1. Well, you got to ask yourself, okay, so how do I find y1? That just means I have to plug it back into a of 30, which we already did in part A, so I don't have to actually go find that value. I know that a of 30 gave us 0.782928. So now we know that this is what y1 is equal to. So my next thing is, okay, well, how do I find m? Well, m is just by finding a prime of 30, which we're going to just take out our calculator again once more. Type in math, go to number 8, dx, type in the equation one more time, 6.687, parentheses, 0.931 raised to the x, and then x equals to 30 because that's what we're looking for. So then we get that our slope, a prime of 30, is equal to negative 0.055976. I'm going to keep a couple decimals because we're going to actually plug this into an equation. So now I'm just going to set my formula, my linear approximation, which is my tangent line. Y minus 0.782928 equals to my slope, which we know what's that, negative 0.055976, parentheses x minus my x1, which is x30. That's my equation. This is my linear approximation. Except always solve for y, so bring this over. So then my next thing is, okay, well, my goal is to find at what time. We got to remember, this is your time value. So you got the first part, now we got to work on the second part. Well, they're saying, predict the time at which there will be 0.5 pounds of grass clipping. Well, that's my grass clipping. This is my y. So I'm going to type in 0.5 minus, and I'm going to plug everything else in. And then I'm going to grab my calculator and just plug everything in. 0.5 minus 0.782928 gives me negative. So since I'm solving for x, I'm going to divide by this. Divided by negative 0.055976 gives me 5.05445 equals to x minus 30. But my goal is to solve for this x, so I'll add 30. And that's going to give me x is equal to 35.0545. Round to 4 decimal places. That's my answer. That is the time for when my linear approximation is going to be 0.5 pounds of grass, 35.0545. And that's your answer. And that right there will give you your 9 points to this first question. So the main thing is when you are reading a question like this, at any part, you always want to break it down. Break down every single part and look for that key word. Part A says average rate. So we knew that was our slope formula. Second question was A prime, meaning derivative. Third question, for what time is the amount of grass clippings, this equation, equal to the average amount? Remember, average is your key word. Average lets you know that you're using your average formula. Once again, average formula, 1 over b minus a from a to b of your function, which was a of t. And then set them equal to and solve it. And then the last one, linear approximation. Linear approximation is your tangent line. Okay? So good luck. Hope this helped. And thanks for watching.